Welcome. This is our chemical equations test tutorial. The practice test was not a formal assignment, but if you're struggling with understanding equations or balancing them, counting atoms, and you need to take the test, then this is really going to be helpful to you. So you can get a paper copy of the test from Ms. Nickel and follow along while she goes through it. The first part is just fill in the blank. That'll be the same on every test. It's talking about law of conservation of mass, which says that matter is not created or destroyed by chemical or physical transformations, which is any kind of chemical reaction or physical change. And according to the law of conservation of mass, the mass of the reactants in the chemical reaction must be equal to the mass of the products. And then when it comes to balancing, we balance equations by changing coefficients. You cannot change subscripts because then you would be creating a new compound. So if you look down here, we're going to go over the different parts of the equation, and then I'll mention a little bit more about coefficients and subscripts. All right, so right here we have an example equation. You'll have a different one on the test. It says label the reactant side and the product side. So reactants are anything that's on the left. It can be one thing or it can be multiple things. It doesn't matter. You can have a reactant or a reactants. And then on the product side, that's always going to be on the right. And same thing again, you can have one thing or you can have several things. All right, so that's reactants and products. Then it says write state of matter. State of matter means solid, liquid, gas, or in the case of chemical equations, we include aqueous. So if you remember, aqueous is spelled like this, and it's something that is dissolved in water, specifically in water. All right, so then if we go through the equation, S means solid, like you would expect. Okay, L, that's an L. It's hard to make it not look like the number 1, so I use a cursive L. L is liquid. AQ is that aqueous, which means dissolved in water. And G is gas. Little arrows in there. All right, so that's how you tell the state of matter. Last thing is that it says to circle coefficients. So we have only one coefficient. That is the 2 in front of water, because a coefficient is always a number in front of a formula in an equation, and it multiplies the entire formula. It's saying I have 2 copies of water or 2 molecules of water in this equation, whereas everything else is just a 1 coefficient, and we don't show 1 coefficients. Then, let's see, I was checking off my little list here, check, and I did do this. And just to point out what subscripts are numbers that are small and come after an element symbol or after a polyatomic ion, which is when you have several element symbols inside of parentheses. And you can have subscripts either on the inside of that or the outside. We'll talk about that more on the next page. All right, so that is the first page of the test. Then if you go to the back of that page, the second page, you're going to see a section for counting atoms and ions. So just to review the way we do that, first thing we do is we list the elements that we have. I have 2 elements, Li and N. I'm going to make a vertical list like this, and then I'm going to set them each equal to their subscript. This is a subscript for lithium. The subscript will come after the element symbol, and it only applies to the element symbol it comes after. So Li is equal to 3. N has no subscript, right? That's a blank there. So it is going to be equal to 1. If there's no subscript, you have a 1. All right, so that one is done. I don't have to do anything else. I go to the next one. Same thing again. Now I have a coefficient, but I'm going to leave that until last. First, I'm going to list the element symbols. I've got Mg for magnesium and P for phosphorus. Then I'm going to set them equal to their subscripts. So Mg is a subscript of 3. Phosphorus subscript is 2. Let's see if these are focusing. There we go. And that's when the coefficient comes into play. The coefficient multiplies everything in the formula. So it's going to multiply the Mg and the P. So this is going to be times 2 equals 6 total magnesium. And this is times 2 equals 4 total phosphorus. Next one, we have Ba, which is barium, and I have one of these things in parentheses. This is a polyatomic ion, but we just treat it as if it were one thing. So we copy everything inside the parentheses, including the parentheses, just like that. All right, then I look after the barium. There's no subscript, so it's equal to 1. And I look after this thing called carbonate, and I look outside the parentheses, right? And there's nothing there, so that is also equal to 1. I ignore any subscripts inside the parentheses. Next, I'm going to use the coefficient. That's my multiplier. That's going to multiply everything in the formula. So this is going to be times 3 equals 3 and times 3 equals 3, like that. My last formula, I have Al, which is aluminum. I list it. And I have SO4. Once again, I've got a polyatomic ion. I copy everything, including the parentheses. Al will be equal to 2. SO4 is equal to 3. Then I multiply by the 2. So times 2 equals 4 total aluminum, and times 2 equals 6 total of sulfate. All right, I am done with that section. Next part. Now, in section 4, it's going to ask you to determine whether or not the equations are balanced. You do not need to put coefficients in these. It's called Is It Balanced? We had a worksheet by the same title. So we are going to count the atoms first. When we count atoms in a chemical equation, it's the same as we did with the formulas, only now we just count atoms from more than one formula. The nice thing for equations is that I give you the list of elements to count, so you don't have to figure out the list. So here Ca has no subscript, so that's equal to 1. H has no subscript, it's equal to 1. This is Cl, remember, not carbon and iodine. C with a line after it will always be chlorine, and it has no subscript, so it's equal to 1. Then I had a coefficient for this formula. It only applies to this formula, nothing else in the equation. But I have to apply it so that I know the total amount of atoms that are represented by this formula. And the 2 also multiplies the Cl because it multiplies everything in the formula. So I have 1 calcium, 2 hydrogens, and 2 chlorines on this side. I go to the other side. I look at the formulas, only 1 calcium represented here. Cl is now in this formula, but it's down here at the bottom. So make sure you put things in the right places. That is going to be equal to 2. And H is also equal to 2. I do not have any coefficients on this side of the equation, so these are my totals, 1, 2, and 2. I compare my sides. I've got the same amount of calcium, same amount of hydrogen, and same amount of chlorine. So this is a balanced equation, and I just circle that. You have to show your work in order to get credit for these. You can't just circle balanced or unbalanced. You will not get any credit for those problems. All right, next part. We have Li, which is lithium, no subscript, is equal to 1, but I have a coefficient of 2, so that'll be times 2 equals 2, and then my oxygen is equal to 2. Over here, Li is equal to 2 because of the subscript, and oxygen is equal to 1. I circle my totals. I compare 2 and 2 for lithium, 2 and 1 for oxygen. That makes this an unbalanced equation. If there are any differences in the totals, it is unbalanced. And I'm done with that side. Okay, now I'm still doing, is it balanced? I'm not balancing equations yet. This is a little bit more complicated example. So we'll start on the reactant side. Carbon is 1. It has no subscript. Hydrogen is 4. And oxygen is 2. There are no coefficients on this side of the equation, so I have my totals. I look over here. I've got carbon here, a 1, oxygen here, a 2, but wait, I have 2 oxygens. That's because oxygen is occurring in this formula and this formula. And when that happens, I put them in separately because I'm going to have to apply the coefficients separately. And then I will add them together at the end. All right, so I'm going to continue. I got my carbon and oxygen for the first formula. Now I go here. Hydrogen is equal to 2. That's the subscript. But I've got a times 2 because of my coefficient. So 2 times 2 equals 4 for that one. And then oxygen, the subscript is 1, so it's equal to 1 times 2 because the coefficient applies to the entire formula. And so that'll be a total of 2. So over here I've got 1, 4, 2, and 2. But these 2's have to get added together because they're the same element. So that's going to be a 4 here. All right, so for this reason, the equation does not balance because I've got 1 carbon on both sides, 4 hydrogens on both sides, but 2 oxygens here and 4 here. So if you were to balance this, you'd have to increase the amount of oxygen on this side. I'm just going to circle unbalanced. Next one. Set them equal to subscripts. Na is 2. Looking outside the parentheses, no subscript, so SO4 is equal to 1. No coefficient on this formula. SR has no coefficient, so that's a 1, and Cl is equal to 2. No coefficients at all on this side, so these are my totals. Over here, Na is equal to 1, Cl is equal to 1, and I now have a coefficient of 2. So I'm going to multiply both of these times 2. Then I count my next formula. Coefficients only apply to the formula they're in front of. SR is equal to 1, and SO4, there's nothing outside the subscript, so that's equal to 1. And so my totals are 1 and 1. If I compare, I've got 2 sodiums on each side, 1 sulfate, 1 strontium, and 2 chlorines. So it looks like this equation is balanced. All right, so that's the end of our Is It Balanced section. The last section of the video is how to balance equations. So right here, balanced equations, and this particular practice test is asking for reaction types. You're not necessarily going to be tested on that. So it depends on the year. I don't always test students on that. If I told you I wasn't testing on reaction type, then I'm not testing on it. But I'm going to show it to you here anyway so that I can use this video for more than 1 year. All right, so when we have a single thing on one side breaking down into multiple things, that is going to be a decomposition reaction. We have something breaking down or decomposing. Decomposition. All right, then I'm going to count. Ni has no subscript. That's a 1. Oxygen is a 3. Ni here is a 1. And oxygen is a 2. My job is to get the two sides of this equation equal. So whenever I have this kind of situation where I have 3 on one side and 2 on the other, my Ni is already balanced. I'm looking at the oxygen. I need to get both of these to 6 to make it balance. And so I'm going to multiply each of them by something that will make the total amount of oxygen 6. So in the case of this nickel oxide, that means I'm going to have to put a 2 in front of it. Always put in my coefficient first. That's going to multiply Ni by 2. And it'll multiply the oxygen by 2 to give us 6. And so then we'll have 2 and 6 there. This oxygen, I'm going to have to put a 3 in front of it. That will increase the amount of oxygen on my product side to 6, which is what I wanted. And then the only thing left is to fix the amount of Ni. I'm going to put a 2 in front of that times 2, and then I will have a total of 2 and 6 on both sides. And that equation is balanced. Next one. First, I list what I have. Na is equal to 2, S is equal to 1, H is equal to 1, and Cl is equal to 1. On the other side, Na is equal to 1, Cl is 1, H is 2, and S is 1. I start at the top of my list and compare. I have 2 here and 1 here, so I need to increase the amount of Na. I'm going to put a 2 in front of my formula that has Na so that I can multiply by 2. So my 2 goes here, then I multiply the things that are in the formula. That's times 2 for sodium and times 2 for Cl. Alright, so now my sodium is balanced, my sulfur is balanced, but my hydrogen is not. I've got 2 hydrogens here and only 1 here. So now I'm going to put a 2 in front of this formula. It is going to multiply this H, which is going to fix my hydrogen problem, and it's also going to fix my chlorine problem, which I hadn't mentioned yet. Alright, so now I have 2, 1, 2, 2, and my equation is balanced. Oh, and I didn't say what reaction type this was. So we have 2 compounds reacting to form 2 new compounds, so we're going to call that double replacement. Okay, now we have a compound reacting with a single element to form a different compound and a different single element. The nickel and the silver trade places. We call that a single replacement. And now we're going to count and balance. Ag is equal to 1. NO3, nothing outside parentheses, so that is a 1, and Ni is 1. On the other side, we have Ag equal to 1, NO3 is now equal to 2, and Ni is a 1. We start by comparing silver, and we're balanced, but nitrate is not, so I'm going to increase the compound with nitrate on this side, put a 2 there because that's what I want to multiply by. I'm going to multiply both silver and nitrate by the 2 and get my new totals for those. I go back to the top of the list and compare, and I see that silver is out of whack. So now I'm going to put a 2 in front of the silver, but that's an easy fix because it is an element by itself. That just multiplies silver. That one's going to be 2. Nitrate was already 2, and nickel is 1 on both sides. Now my equation is balanced. Next one. We have another double replacement. 2 ionic compounds. They are trading partners. Barium drops chlorine and picks up sulfate. Sodium drops sulfate and picks up chlorine. So we call that a double replacement. 2 compounds switching partners. All right, so we count. Ba is equal to 1, Cl is equal to 2, Na is equal to 2, and SO4 is equal to 1. On this side, Ba is equal to 1, SO4 is equal to 1, and Cl and Na are also equal to 1. When I compare the two sides, I notice that the first thing I notice out of whack is that I don't have enough chlorine on the product side. So I'm going to multiply that by 2 by putting a 2 in front of barium chloride. So this will be times 2. Wait, what did I just do? I just did something crazy. Okay, I'm going to start over. See, everyone makes mistakes, guys. I needed more on this side, and that's a common mistake. We increase on the wrong side. All right, I need to multiply on this side, and my compound that has chlorine on this side, I'm going to put a 2 in front of it. So that's going to be Cl times 2 equals 2, and Na times 2 equals 2. And that was a really nice fix because look at this. We are completely balanced. Same numbers on both sides. Okay, so hopefully that gave you the idea for all those different skills in our balancing equations unit, and I think you should be ready for the test now. I will see you in class.